Time. It's the one thing we all think we understand. Seconds pass, days go by, and the future awaits. But what if I told you that everything you believe about time could be wrong? What if time is hiding a terrifying secret, a paradox so destructive it could unravel the very fabric of reality? This isn't science fiction. This is a very real fear that's been keeping some of the world's greatest scientists awake at night. The illusion of time. Every morning the sun rises. Time ticks forward 1 second at a time. We wake up, we go about our day, and before we know it, another evening has come. It feels natural, doesn't it? The flow of time is something we've always accepted, a constant that governs our lives. We plan for the future, reminisce about the past, and live in the ever-shifting present. But what if I told you that this seemingly straightforward flow of time is nothing more than an illusion? For as long as humanity has observed the universe, we've understood time as a linear path, moving from past to present to future. It's the foundation of everything we do. But here's the unsettling truth. Time may not work the way we think it does. The more we've studied the nature of time, the more scientists have begun to suspect something extraordinary and terrifying. What if time isn't flowing forward at all? What if it could stop? What if it could reverse? The idea might sound impossible, even absurd, but the laws of physics don't demand that time moves in one direction. The very concept of time's arrow, the idea that time is always marching forward, may just be an illusion, a convenient lie we've told ourselves. Physicists have long studied the arrow of time. At first glance, it seems simple. Time moves forward, always. But why? What force drives this relentless progression from order to disorder, from the past into the future? The answer lies in something called entropy. Entropy is the measure of disorder in a system. According to the second law of thermodynamics, entropy always increases. That's why things fall apart, why glasses shatter but never unshatter. This increase in entropy is what creates the illusion of time's forward flow. As the universe becomes more chaotic, we experience the passage of time. But here's the catch. The laws of physics, as we understand them, don't actually require time to move forward. There's nothing in the equations that prevents time from running backward, or even stopping entirely. In fact, on the quantum level, time behaves in ways that defy all logic. It can loop, reverse, and even split into multiple possibilities. And if time can reverse, even for a moment, what happens to everything we know? To the lives we've lived? To the memories we've made? If time stops moving forward, does everything collapse? Do we become trapped in a loop? Or worse, does reality itself begin to fall apart piece by piece? What scientists have discovered is deeply unsettling. The rules that we believe govern the universe may not be rules at all. Time could, under the right conditions, behave in ways we can't even imagine, ways that could terrify even the most brilliant minds among us. And that's where things get truly dangerous. Because if time can break, then everything else can break with it. The arrow of time, why it might break. Imagine a glass of water sitting on the edge of a table. Suddenly it tips over, crashes to the ground, and shatters into 1,000 tiny pieces. The process is irreversible. You can clean up the mess, but you can't put the glass back together as it was. This is the natural flow of time, driven by a concept we call entropy, the relentless march from order to disorder. Entropy is the reason time moves forward. It's why we experience life as a sequence of events: birth, growth, aging, death. But what if that process could be reversed? What if entropy didn't always increase? What if, instead of time marching forward, it could, rewind? In theory, there's nothing in the laws of physics that explicitly prevents time from flowing in the opposite direction. If entropy could be reversed, so could time. And if time rewinds, everything you've ever done, everything you've ever experienced, could simply unravel. Your memories, your actions, your very existence could be undone in an instant. Everything you are could be erased as though it had never happened at all. And here's where it gets even more disturbing. Some scientists believe that under certain extreme conditions, like near a black hole, where the fabric of space-time is stretched to its limits, or in the quantum realm, where particles behave in ways that defy our understanding, time could break free from its usual flow. It could stop moving forward entirely. Or worse, it could splinter, creating a chaos of fractured moments. What happens then? Could reality itself collapse under the weight of these broken timelines? Could the memories you've built your entire life around simply vanish, as though they were never real in the first place? And if time can shatter like glass, what would that mean for the universe? Could we be living in a fragile existence teetering on the edge of a temporal breakdown? Could everything we know just disappear forever? The grandfather paradox. Can we unmake ourselves? Imagine for a moment that you could step into a time machine. The gears begin to turn, the lights flicker, and suddenly you're no longer in the present. Instead, you've traveled backward in time, arriving decades before you were ever born. Now, let's imagine something even more extraordinary. In this past, you encounter your grandfather before he ever met your grandmother, before your parents were born. You approach him realizing that any action you take here could alter the future in unimaginable ways. But then, a chilling thought crosses your mind. What would happen if, in this moment, you accidentally stopped your grandfather from meeting your grandmother? This is the grandfather paradox, a simple yet terrifying thought experiment. If you prevent your grandparents from meeting, you prevent yourself from being born. But if you were never born, how could you have traveled back in time in the first place? Would you simply cease to exist, unmaking yourself with a single decision? This is where things become deeply unsettling. If you unmake yourself, what happens next? Does the entire timeline collapse under the weight of this paradox? Or does reality simply correct itself, creating a new timeline where you never existed? Scientists have wrestled with the implications of this paradox for decades, and the answers are far from clear. Some believe that a new timeline would emerge, one where you were never born, but the rest of the universe carries on. Others fear that such a paradox could cause the entire structure of reality to break down. If the timeline can't reconcile your existence, could it all disintegrate into nothingness? Could the paradox unravel the logic of the universe itself? But here's where it gets even stranger. What if I told you that these paradoxes aren't just theoretical? That time travel paradoxes could already be happening right now around us? The universe is full of strange, unexplained phenomena. Events that defy logic and challenge our understanding of time and space. Could we be witnessing the effects of broken timelines, or worse, the slow unraveling of reality? Are we already living in a universe where paradoxes have left their mark? And if so, how long before they tear everything apart? Quantum time, the world where time breaks down. We live in a world governed by the steady flow of time, seconds ticking by, events happening in sequence, cause leading to effect. But deep beneath this familiar reality lies a world where the rules of time begin to break down. This is the quantum world, where particles behave in ways that defy our everyday experience. In this strange subatomic realm, time is not as straightforward as we believe. Imagine a particle, an electron, existing in two places at once, or a photon that can travel backward in time. These are not science fiction fantasies. These are the realities of quantum mechanics. In the quantum world, particles don't play by the same rules. Time doesn't move forward in the orderly fashion we experience in our daily lives. Instead, it loops, twists, and even reverses. At the quantum level, particles exist in a state of superposition. They can be in multiple places at once, experiencing multiple possibilities simultaneously. And when observed, they seem to choose a single outcome, collapsing into one point in time and space. But here's where it gets even stranger. In some cases, particles appear to move backward in time, as if they've somehow broken free from the rules that govern our reality. This discovery has left scientists puzzled and even unnerved. If time can flow both forward and backward at the quantum level, what does that mean for our understanding of reality? Could time itself be flexible, looping and branching in ways we can't yet comprehend? What if time isn't a single, fixed stream, but a vast network of possibilities, each one splintering off into new timelines, new realities? Quantum entanglement is one of the most mysterious phenomena in physics. When two particles become entangled, Their states are linked, no matter how far apart they are. If one particle changes its state, the other reacts instantly, even if they're light years apart. It's as if time and space no longer apply to them, as if these particles are connected beyond the constraints of our universe. But here's the question that keeps scientists up at night. If time can behave so unpredictably in the quantum world, what's stopping it from happening in our world? Could the strange, chaotic nature of quantum time eventually ripple out into the universe we live in? Could we be on the brink of a reality-breaking event triggered by these bizarre quantum behaviors? We don't yet understand how or if these quantum effects could affect the flow of time in our everyday lives. But one thing is clear. The deeper we look into the quantum realm, the more we realize how little we truly understand about time. And if time can unravel at the quantum level, what does that mean for the future of our universe? The Boltzmann Brain paradox. Are we even real? The universe is vast, seemingly infinite. Billions of galaxies, trillions of stars, and even more planets fill the cosmos. But amidst all this grandness, there's a paradox, a thought experiment so strange, so unsettling, that it could make you question your very existence. It's called the Boltzmann Brain paradox. Here's the paradox. According to the laws of thermodynamics and statistical mechanics, it's theoretically more likely for a fully formed brain, complete with false memories, thoughts, and experiences, to randomly pop into existence in the middle of this cosmic void than for the entire universe, with all its complexity, to have formed the way it did. Think about that for a moment. What if right now everything you've experienced, every memory you hold dear, are nothing more than a fleeting illusion, a temporary existence that emerged randomly from the chaos of the universe, only to disappear just as suddenly? If the Boltzmann brain theory is true, then nothing is as it seems. Your past, your identity, the very fabric of who you are, could be nothing more than a cosmic accident, a random fluctuation in a sea of chaos. Your memories, carefully constructed and deeply meaningful to you, might not have ever happened. In fact, they might not even exist beyond this moment. But here's the truly terrifying part. If you are a Boltzmann brain, if we all are, then this existence could end at any moment. There's nothing anchoring you to reality. No past, no future. Just a brief flash of consciousness in a universe that doesn't even know you're here. So, are you real? Or are you just a temporary figure destined to vanish as quickly as you arrived? And if reality itself can flicker out like a dying star, what does that say about the universe? About us? Time dilation and the black hole of time. In the farthest reaches of the universe, where the laws of physics begin to break down, lies one of the most mysterious and terrifying phenomena known to science: the black hole. A cosmic vacuum, pulling in everything around it: light, matter, and even time itself. As you approach the edge of a black hole, something truly strange begins to happen. Time, as we know it, no longer behaves the way it should. This phenomenon is known as time dilation. The closer you get to the immense gravitational pull of a black hole, the more time slows down. What might feel like just a few minutes to someone near the black hole could be thousands of years for someone observing from a safe distance. Seconds stretch into minutes, minutes into hours, and time itself begins to warp beyond recognition. But what happens if you go even closer? As you approach the event horizon, the point beyond which nothing can escape, not even light, time slows further and further until it nearly stops. For someone falling into the black hole, time would stretch into an eternity. From the outside, it would appear as though they were frozen in time, forever suspended at the edge of the void. But what happens beyond that? What happens when time stops altogether? Here's where things get even more mysterious. Once you cross the event horizon, all bets are off. Scientists still don't know exactly what happens inside a black hole, but some theories suggest that time could do more than just slow down. It could stop, or even unravel entirely. Inside a black hole, the fabric of space-time may fold in on itself, creating a singularity, a point of infinite density where the known laws of the universe break down completely. And if time stops or unravels inside a black hole, what's stopping it from happening elsewhere? Some scientists believe that the extreme conditions inside black holes could cause more than just localized time dilation. What if the effects of a black hole's time manipulation don't stay contained within the event horizon? What if, in the right circumstances, the slowing or stopping of time could ripple outward, spreading through the fabric of the universe itself? Imagine a universe where time itself begins to slow down, not just near black holes, but everywhere. Seconds stretching into eternity with no way to move forward. Planets orbiting their stars, slower and slower until eventually everything stops. If time can be stopped inside a black hole, what's stopping it from happening across the cosmos? Could we all be living on the edge of a cosmic time collapse, one that we're completely unaware of? And then there's the most terrifying possibility of all. What if time, once stopped, can never start again? Could the universe be destined to reach a point where time itself freezes forever? A cosmic halt where everything remains locked in place for all eternity? Scientists are still trying to understand the nature of time near black holes. But if the fabric of time can unravel in one part of the universe, there's nothing to say it couldn't happen everywhere. What if we're closer to that edge than we think? If time can stop inside a black hole, what's stopping it from stopping? Everywhere. The ultimate fear, the end of time. Time, the very thing that defines our lives, that orders the universe, that shapes reality as we know it, may not be infinite. There is a growing belief among scientists that time could one day come to an end, a point where time ceases to flow and the universe enters a state of eternal stillness. But how could this be possible? The key to understanding this lies in the second law of thermodynamics, the relentless force of entropy. Entropy measures the amount of disorder in a system, and according to this law, entropy always increases. Over time, the universe is moving from order to chaos, from complexity to simplicity. Stars burn out, galaxies collide, and eventually even black holes evaporate. Every process in the universe contributes to the slow, inevitable increase in entropy. This gradual increase in entropy leads to what scientists call heat death. The universe is constantly expanding, and as it does, the energy that fuels the stars, planets, and galaxies is spread thinner and thinner. Eventually, in the far distant future, the universe will reach a point where there is no usable energy left. Stars will have burned out, no new stars will form, and black holes will evaporate into nothingness. All that will remain is a cold, dark void where nothing changes, because there is no energy left to drive change. At this point, time itself could cease to exist. In a universe where nothing happens, where no processes unfold, there is no need for time. Time, as we understand it, only has meaning when things change, when events follow one another. But in the distant future, after the heat death of the universe, there will be no change. No motion, no life, nothing. This is the ultimate fate that some scientists fear, the end of time. A moment when the universe reaches a state of complete and total equilibrium, where all energy has dissipated and nothing remains but a cold, unchanging void. Without motion, without heat, without light, time would have no meaning. The very fabric of reality could collapse into a state of eternal nothingness. It's hard to imagine, isn't it? A universe without time, a reality without events, without progress, without life. And yet, according to the laws of physics, this could be the inevitable end for everything we know. It might not happen for trillions upon trillions of years, but the universe is already on that path. Every star that burns out, every galaxy that fades, brings us one step closer to this ultimate fate. So what do we do? Do we simply accept that time is a construct destined to unravel? Do we resign ourselves to the fact that one day, far in the future, the universe will slip into a state of eternal silence? Or is there still hope? Could there be secrets hidden within time that we have yet to unlock? Is there a deeper understanding of the universe that could prevent this ultimate end? Perhaps there are forces beyond entropy, beyond the heat death, that could keep the universe alive in ways we can't yet imagine. Physicists are still grappling with these questions. Some believe that new discoveries, new understandings of time and space, could open doors to a different future. Theories of quantum mechanics, dark energy, and multiverses might hold the key to escaping the fate of heat death. Could there be alternate timelines or parallel realities where time flows differently? Could there be forces in the universe that we haven't yet detected? Forces that could reverse entropy or restart time after it ends? We don't yet know the answers. But one thing is certain: time is far more mysterious than we ever imagined. And until we unlock its deepest secrets, we will continue to live in the shadow of its inevitable end. So the question remains, is the end of time truly unstoppable? Or could we, somehow, find a way to rewrite the future of the universe? The paradox of time is more than just a thought experiment. It's a real, terrifying possibility that could change everything. And until we truly understand it, we remain at the mercy of its mysteries. If you want to dive deeper into the mysteries of time, space, and the universe, make sure to subscribe and hit that notification bell, because there's much more to uncover in the endless maze of time.